Welcome everybody to this session about automotive architectures and networks evolution. I'm Andreas Stark. I'm a systems engineer in the transportation business unit, National Instruments. And I've been working over the past couple of years with Martin and Guillaume and their team with integrating RESPA simulation. I'm really happy to host this interview today and talk through the challenges in testing ECUs. All right. Yeah, Martin and Guillaume, thanks for making it. And yeah, would you mind introducing you briefly and also talk a little bit about what AKA is doing and how you're helping test engineers to master their challenges?
Sure. Thank you, Andreas. So I'm Guillaume. I'm PROVEtech ABS product manager. And I'm also the principal contact between AKA and NI.
Welcome also from my side. Thanks, Andreas, for the introduction. My name is Martin Witter. I'm a product manager for the PROVEtech tools and yeah, working for AKA since 12 years. And yeah, AKA is providing solutions for validation since a long time to help the test engineer to work efficiently and with the hardware from National Instruments.
All right. Also, can you talk a little bit about the other areas where your colleagues at AKA are working in, other than just the test tools?
Yeah, sure. So as you may know, so AKA is a worldwide servicing company. So we provide services to our customers. So we are working in all the fields, so railway, aerospace, automotive, medical. And we have about 21,000 collaborators. And as you mentioned, so here in Germany you have, and also in AKA, we have a huge expertise into testing. So we cover the complete process, so from test strategy management to the testing itself, and also with our team where we develop tools to perform those tests. So our goal with PROVEtech ABS is really to easy the work from test engineers and let them really focus on their work to write a test and make them running instead of developing the infrastructure needed to run those tests.
All right. I mean, yeah, that's really great to bring these both expertise together, the test resident engineers that you're having and working directly with your customers on test projects, as well as the tool side and integrating this feedback and knowledge and know-how into the testing tools. All right. So my next question would be, what challenges are our test engineers facing today and tomorrow in the automotive area?
Yeah, our colleagues have the topics that the complexity is much increasing. For example, topics like connectivity, ADAS, autonomous driving, e-mobility. So it's a big change from the classic vehicle technology to the new one. And with the new technology, it's not only complexity increasing, also diagnostic. We have over-the-air updates. We have cost reduction for everybody. We have late hardware and documentation availability, new standards, and a lot of learning for all the test engineers. And we will help them with our tools to also fit for the future, like scenario-based testing that you need also in the future for the ADAS functionalities.
Yeah, I think that's really good to hear. Yeah, for me, also it feels like the wheel is spinning faster and faster, and the new technologies are introduced even faster and faster. And we know there's a lot of new players in the market setting the pace, and then making it really challenging for everybody to keep up. Okay, then yeah, let's talk a little bit about the electrical and electronic architecture of the vehicles and how they evolved over time, and what are the driving factors right now, basically, to solve all these challenges.
Yeah, as you said, we were on a time where everything is evolving really quickly. So now we have really high advanced driving assistance systems, really complex. We are going in the way to have autonomous driving vehicles. And maybe then fully automated autonomous driving vehicles in some years, that it requires much more cameras, much more radars, lidars, which implies then that you have in the car much more data flow and that you have to compute everything. So as everything is interconnected. So when you were before to like a spread architecture with many ECUs that had their own functions, now you tend to have, let's say, one big one that will have much more higher computation performances and that will gather all this information.
Okay, and then so we have all these new features, the complexity. We have this central architecture now because we just need to have access to all the information in the vehicle to provide complex functionality like a parking assistance where it's cameras and driving and powertrain. All these domains need to be connected, right? Right. So well, what is the solution to all this complexity? What are many companies are leaning towards, and what are they using as an operating system of the vehicle to simplify and basically handle all this complexity in the software?
So more and more OEMs using Autosar, that means Automotive Open System Architecture. So it's a free layer architecture between for the developer. It's the basic software, the runtime environment, and the application layer. So it's an open standard to work together to find solutions for the new approaches, and also with the time. So it started nearly 20 years ago. It's changing also now from a classic foundation and adaptive Autosar. So from the normal signal-based communication to event-based communication. And for the test engineer, I think also the communication is much more important. With the residual bus simulation, you have standardized Autosar XML files, and the tools have to take care about the parsing of the files and to generate this residual bus simulation to test your devices.
Okay. Also, I think one important aspect of Autosar, like how does it make components more reusable? And how does it kind of like influence the test engineer in that regard?
Yeah, so the idea is, okay, you can put some software part on from one ECU to another, and from the runtime environment take care about this. So this should be much easier, and you are much free to plan your architecture, and that's helpful. What Guillaume mentioned before, to have these new architectures. And you have standardized components, and that makes it easier for the supplier to deliver the same standardized architecture also to different OEMs.
Okay, that's great. So we have our apps in the ECU that we can move around and reuse and test better, test more, as it's not a one-off. Of course, I think Autosar is a complex standard. It's evolving rapidly over time as well. So you need some partners that keep up on the latest developments. So how are you keeping up with the latest developments in Autosar?
So we follow our release from the Autosar, so with the spec and requirements, and we also always receive from our customers so their needs regarding those new requirements from Autosar. So we know what they want, and then we develop the solution for it. And then also we have the case then with some new OEMs, some new actors in the market where they start to use this standard, and we also kind of give them feedback about what they are doing. Okay, I mean that's great to hear. I guess like the early involvement in these projects where these new features of Autosar are being used is key to gather that knowledge and then work with your customers to actually make it successful and then also integrate it into your tools. I mean, one of the drivers or the enablers of all this communication technology is Automotive Ethernet with ever increasing bandwidths. But so what additional challenges does Automotive Ethernet versus like the classical well-known CAN bus provide for the test engineer? Yeah, so Automotive Ethernet is quite new. it contains a lot of protocols. So you can have like UDP for control traffic. You can have some IP for all the service communication, some video protocols, TCP to IP for diagnostic. And you kind of have to understand everything in order to use it efficiently. And as you mentioned, so it's the perfect solution because it offers like brighter bandwidth. It researches the complete network from the car. But then it has also much more challenge when you speak about thematics such as security, encryptions about the frames.
So I see. So it's not just like one bus now, but we have a network with multiple protocols, and they can be very complex to handle. Well, so then my last question is for this short session: how does a typical, ECU test look like, and what are the components needed to be successful in testing such an ECU?
Yeah, it depends on which part of the V model on the right side you are working, or if it's component testing, if it's integration testing, or system test. So the most important parts are you need a REST bus simulation to make your device for no test happy. So you have measurement and calibration like the SMXCP, or of course also diagnostic to take care that you can read the defaults of the error memory. And if you start the testing, so if you have the requirement, you write your test script, you have to turn on the power the power of the device. You have to read and write inputs and outputs. You have to prepare the device for test mode. Maybe you have also need raw frame access, so you start the tracing, and also during the test you make measurements and using the calibration parameters. And at the end you have to be sure that you know, okay, the functionality of the to test function is fine, and you can at the end know, okay, everything is fine. And according to this, you need the tool with all the functionalities that are necessary and that you can run the precondition, the test steps, and the post condition.
All right, thanks for running us through. There's another session about walking through the demo of the REST bus simulation, so feel free to take a look at this. Thank you very much, Martin and Guillaume, for taking the time and discussing all these questions with us. Thanks everybody for listening in, and enjoy the rest of the Automotive Exchange event. All right.
Thank you, Andreas.
Have a good one.
Everyone.
Yes.
Bye-bye.